All right, we are covering endocrine system part 2. So this is the pituitary gland here, just to remember where that's located. If you look at the brain, in the center of the brain, hanging down is this tiny light pink gland, is the pituitary gland. Very kind of almost in the center of your skull, if you will. The hypothalamus is this bluish purple region. It is part of the brain. And so this is real brain part. This is an actual gland, just like an endocrine gland. This is the part of the brain that controls and regulates all the endocrine glands. So controls and regulates the whole endocrine system. And this is a gland that is also has a similar function, a gland that kind of stimulates and regulates many other endocrine glands. So now we're zooming in on this, and here we have the hypothalamus, and here we have the pituitary. It exists in 2 lobes. So I want you to be able to recognize these pictures. So I zoomed in on them just so you could be able to recognize them visually. Okay. So here we have, these are just a quick comment. These are obviously all the glands that the pituitary stimulates and or regulates, that it controls. So these are the sex glands. These are the ovary. You can see the little oogenesis in there. The testes. These are bones and muscles, and this has to do with growth hormone. Growth hormone stimulates growth in bones and muscles. This is kind of a weird picture because it's a breast that's been, you could see the inside of it. And so it's the mammary glands. This is an adrenal gland. If you remember, these are the glands that are right on top of the kidneys. In fact, let me just jump down and give you a visual. See, these are the adrenal glands, and they're giving you a view, a cross-sectional view of it. This is the thyroid. It's the one that is right, your voice box will be right above it. It's basically on your trachea. If you point to your throat, just under your voice box, it's here. This is mammary glands and uterus. Right? This is the uterine muscle. Can you remember which hormone affects both mammary glands and the uterus? It would be oxytocin. And lastly, this is the kidney, because there are hormones which control and regulate how the kidney works, how it controls fluid concentration. So what is the point of this? It's to show you that the pituitary gland makes a set of glands that I think the best way to summarize them is to call them it makes a set of hormones set of hormones that are called regulating or stimulating hormones, because they do just that. They stimulate and they regulate many other endocrine glands. Okay, so it's an endocrine gland which makes hormones that control other endocrine glands. So you don't need to know the names of all of them, just know what things they control. There's 3 of them whose names you need to know. And on your worksheet, those are the ones by which I put the asterisks. On your worksheet, go ahead and label all these organs so you can understand all the organs that the pituitary affects, and then label these 3. So the first one would be this. Can you guess which hormones these are? The pituitary makes which hormones controlling the sex glands, and that should be FSH and LH. You probably remember that. Know this one because it's kind of a cool one to know. It's a growth hormone which affects bones and muscles, and this is one which it's not a regulating or stimulating hormone. It's a direct impact. It directly affects bones and muscles. It's not working through another endocrine gland. And know this one because we learned a lot about oxytocin. So this affects the uterus and mammary glands. And that's it. You don't need to know the names of these other hormones. Okay, so that's the big picture again. Hypothalamus influences the pituitary influences all these things. Okay, I think we had already looked at this. So if you remember, the adrenal glands, the outer part is the cortex, the inner part the medulla, and they make stress hormones. Blood flow is controlled by either dilate. This is a normal blood vessel. It can be dilated to increase blood flow, or a blood vessel can be constricted to reduce blood flow. And so this is my question for you. In a moment of intense stress, which parts of the body would need increased blood? Which parts of the body could have lesser blood flow because they're not essential to the emergency that's going on? And hopefully if you think it through, we're looking at especially these 2, this would make sense. Brain, muscles, and lungs. So physical activity with the muscles and the lungs, and clear thinking are really important in an emergency. And these things are less important in emergencies, right? And that is why this is a really interesting thing to know. Intense stress over a prolonged period of time will often cause problems to these systems. So the first thing is that you don't digest well, you can get stomach aches, you can get all kinds of digestive problems um, when there's less blood flow to your digestive system. Some people get diarrhea, some people get stomach aches, some people aren't hungry. Um, you can also get sick more easily and if you are stressed out for a long period of time. And some people even have difficulties with infertility for long-term stress. And then these are important also. Adrenaline increases heart rate and breathing rate. Adrenaline increases the glucose metabolism, how quickly your body takes in and uses glucose. Your cells take in and use glucose. You know what? I just feel like I did not introduce this whole thing with the primary stress hormone we're looking at is adrenaline. It's also called epinephrine. Um, and these are its effects. And then the other stress hormone is corticosteroid. It's called corticosteroid because it's made in the cortex of the kidney. And it's less easy to understand than adrenaline. So we're really just going to focus on the two bold-faced parts. Corticosteroids affect what the kidneys do. They affect fluid concentration by affecting the retention of water and electrolytes. Remember, the kidneys are the ones that balance fluid concentration in the body. Corticosteroids also are involved with immune suppression. I think for the same reason adrenaline is. It's when you're under stress, it seems like the immune system is not of an essential immediate need. And so it kind of tells the immune system to calm down and not work so hard. And so I think for the same reason that adrenaline does. What ends up being really important, and this is why I brought this up, is because corticosteroids are really useful in a host of medical problems. When would an immune suppressing and an anti-inflammatory, anti-inflammation medications are immune suppressing because inflammation is part of the immune response, right? When would they be useful? Well, lots of occasions, right? All these things involve inflammation getting out of hand, and corticosteroids are useful. If you have asthma, your long-term inhaler is a corticosteroid that you inhale. If you have eczema or other creams or other rashes, the hydrocortisone creams are corticosteroids, and so on. Okay, let's move on. Here's the last part of endocrine system. We're going to look at the pancreas. If you remember, the pancreas was one of the accessory glands of the digestive system. This is where we learned it before, right? Here's the liver, here's the gallbladder, here's the pancreas. It's got kind of a bumpy appearance, as many glands do. We learned about it for doing what? Secreting enzymes. I think at the time we called it a trio of enzymes. A trio because it secretes enzymes that digest carbohydrates, lipids, and proteins. And so it makes these enzymes, and you see this little pancreatic duct. This label is a label of this duct here. You need to understand this for the next slide. And notice they're hard to see, but there's little branchings off of this duct. And what flows along this duct is the enzymes that the pancreas makes. They flow along it, and then they flow into the small intestine. Remember, the first part of the small intestine is called the duodenum for digestion of all the food that we've eaten. This is food that's just entered the intestine from the stomach. Okay, so when you make and secrete something, you're called a gland. Making and secreting enzymes makes you an exocrine gland, right? The pancreas is an exocrine gland because it releases digestive juices. The pancreas is also an endocrine gland. In other words, it also makes and releases hormones. So that's what we're going to look at now. What hormones does the pancreas make and secrete? Well, let me give you first a quick summary, the one-line summary. The pancreas makes and secretes hormones which control blood sugar. Okay. All right. So this is zooming in on the structure of the pancreas. So here's our pancreas. Right here is a cut or cross section, and this is looking at the cross section. So it's as though we turn this pancreas towards the screen and it's facing you. And this green part here, the little branches off, is a part of the pancreatic duct. So it's part of this duct here. And these things coming out are little branches of the pancreatic duct. And so what's interesting about the pancreas is that it has clusters has two different types of cells, which are completely different. Some of them make enzymes, exocrine cells. Some of them make hormones, endocrine cells. And their cells are clustered into little islands. And you can figure out where which type of cell there is based on where they are. So if you look at the blue cells are clustered around the pancreatic duct, right? They're clustered around the pancreatic duct. Why? Because they make enzymes, so they're exocrine cells, which are going to immediately be secreted into the pancreatic duct, and then they would flow, I guess, into the screen to flow down into the intestine. So here's a close-up of it. Here's the exocrine cells making enzymes. The enzymes flow into the pancreatic duct, flow into the central and pancreatic duct, and flow down. All right, then there's these other types of cells which come in islands, in big clusters, and here they're represented as pink. And this red thing is a tiny blood vessel. And so they are clustered around the blood vessels. Why? Can you guess what kind of cells these are? They're endocrine cells. In other words, they're making hormones. And when they make hormones, where do they go? The little black arrow shows you the hormones they make go into the blood vessel because hormones travel through the bloodstream. Okay, so that's just a look at the structure of the pancreas and how its structure and its function match up. This is another picture. I guess here the green is the pancreatic duct. These are the enzyme-making cells, or exocrine cells. These, with the blood vessels in them, this is a big island of endocrine cells, or hormone-making cells. Okay, this is an actual photograph, so you can see it. Endocrine cells, exocrine cells. So it really is the way this pancreas is structured. This is on your worksheet. If you can tell, these off-whitish clusters of cells, they're on the pancreatic duct. So you can figure out what type of cells they are, right? Okay, so now we're going to deal with blood sugar. So the overall function of pancreatic hormones is to control blood sugar, okay? So I have this, maybe it's kind of a strange analogy, but I wanted to go over the biochemicals that give us energy. So this is supposed to represent something that's immediately available. You can start building with this right away. This is a little bit stacked up and tied up, so you'd have to unpack it or break it down chemically, but it's pretty easy to do so. And this is extremely efficiently and densely packed up and hard to reach, right? All tied up and reached high. And they represent three different types of biochemicals. So the one that's offers you immediate use for immediate energy is sugar, and it's also short-lived, right? Not a whole lot of lumber there. Then there's glycogen, which is the stored fuel that we find in our liver and in our muscles, but especially in our liver. It does need to be unpacked, does need to be broken down chemically, and it will provide energy, but it doesn't take too long to unpack, right? Your body, when it runs out of fuel, as soon as you get a little bit hungry, it will start to break down glycogen and get energy from it pretty quickly. And then lastly is fat, right? Truly, it's called a triglyceride. And fat is a lipid, which is also stored fuel, which does need to be unpacked, that is broken down chemically, but which takes quite a bit of work and a longer amount of time to break down chemically. So it will provide you energy. In fact, it'll provide you lots of energy. This represents a lot of lumber, but it takes longer to access it. Okay, so this is the analogy: sugar, glycogen, fat. And this is important for remembering what biochemicals do, but also for understanding what the pancreas does. So the pancreas makes insulin and makes glucagon. So insulin is what your pancreas secretes when there's high glucose levels, and glucagon is what your pancreas secretes when there's low glucose levels in your blood. So skip this, let's go to this. This is really important. The target cells of insulin are liver, fat cells called adipose cells, and skeletal muscles. They're the same target cells of glucagon. What is insulin? So insulin is the hormone. It's the pancreatic hormone secreted when you have high glucose in your blood. And what does insulin tell the liver? Take glucose in, convert it to glycogen, and store it. What does it tell your fat cells? Same thing. Take glucose in, convert it to fat, and store it as fat. What does it tell your muscle cells? Take glucose in and use it. Skeletal muscles use glucose for energy. So glucose is being removed from the blood, taken into cells for use or for storage, and the overall effect is lowered blood sugar. Glucagon is the hormone that the pancreas releases when there is very high blood sugar, And what is the purpose of glucagon? It does the exact opposite thing. Break down the glycogen, turn it into glucose, and release it.